The next tool what we are going to study, like, or you can say the tools which we studied, like the symbols, the valencies, will be now used in writing the chemical formulas, right? You know that if you just remember the valencies, and if you can just recall the valencies in a proper manner, there is the chemistry is not going to be difficult for you, because you just need to write the valencies and the chemical formulas will be on your tips, right? So see, just look at the board. I am just telling you the rules, that how you can write the chemical formulas, how you, like, you can just randomly say the formula of the compound, but just you don't need to cram it, right? So just look at the board, and once you will be thorough with the procedure, it won't be a tough task for you. So before we start the chemical formula, we should know that there are three kinds of compounds that we often come across. There are the compounds which are made up of metal and non-metal. There are the compounds which we come across, that is non-metal and non-metal. And sometimes we come across a compound which carries the two elements along with oxygen. So there is, you can say, a different technique of just making the chemical formulas, or you can say by there is a technique of just naming them, right? So just look at the boards, you'll know everything now. So when there is a compound between metal and non-metal and you need to make a chemical formula, so first of all start with metal, right, like this, and the second letter which you have to write by leaving a small space between them will be a non-metal, right. The second step which you have to do is just write their valencies on the top. For example, in this case I am taking the valency of metal as positive and non-metal as 2 negative. It can be, you know, if you will remember the valencies, so just write the valencies of the particular element which you are asked to make the chemical formula, right. So just write their valencies, then just crisscross them by interchanging their valencies. Write the valency of this on its foot and the valency of the second on the foot of the first, right. So the first of all, when you are crisscrossing them, don't change the places of the metals and non-metals, they will remain as such. What you have to do, you just have to just cross the valencies, and when you are crossing the valencies, don't write plus or you can say positive or negative signs on the foot, you just need to write the number, right. So here is the plus means when there is no number, that indicates 1. So that means I have to write 1 and this side. I may write or not, it means the same, so I am not writing it, right. So the valency of non-metal is 2 negative, that is 2. So I am writing on this foot. So the formula becomes like this, right. Now I am stating this with an example. For example, I take an example of you can say the magnesium nitrite. Magnesium nitrite. Now out of it, what is metal? Magnesium. So obviously we are going to start with the metal. So I have written metal Mg. The symbol for the magnesium is, you know, that is Mg. Nitrite means nitrogen, so I am writing nitrogen. The second step, just write the valencies. I remember those valencies, so I just wrote them. And if I forget it, so just simply write the atomic number, write the configuration, write this, yes, 2 positive, valence electron 2, that means it is going to show 2 positive, right. And if you just remember the valencies chart, so just, it is a tricky part, that just write the valencies on the top. You don't need to write the atomic number, no, don't need to write the configuration or such that, right. So the third step is that to crisscross them. So I know that I don't have to interchange the places, so I am not interchanging the places, I am just making them closer, because now they will be behaving as one unit, right. So I am just, I have just written them, you can say I have just decreased the space between them. Now the fourth step is that I have to write the valency of this on this foot and the valency of this on this. I have to interchange the valencies, and the one thing I need to remember, when I am interchanging the valencies, I don't need to write the positive or negative signs. That signs only matter when we are writing the first letter and the second letter, so that there is no confusion that we have to write the metal first or non-metal first. It is always the element with the positive valency which is written first, right. So I am just interchanging the valencies. The 2 positive, that means 2 is going to be on the foot of the N and 3 is going to be on the foot of this. So this is the formula for the magnesium nitrite, right. And one more thing you need to remember, whenever we are naming a compound formed of metal and non-metal, how we name it, we have to write the name of the metal. So this is metal, so I am writing magnesium, right. And what you do, and in case of non-metal, I know it is the nitrogen. So what will be done? Like at the end of the nitrogen, that means the suffix will be going to change. It will no longer remain as nitrogen. Its suffix will be IDE now. So that means it will become nitride. So therefore, this name is not magnesium nitrogen, it is magnesium nitride, right. So this is how you are going to make the chemical formulas between the metals and the non-metals, right. Now we will be taking up the compounds between non-metal and non-metal. So how I will be making a compound between non-metal and non-metal? Like for example, when we are naming the compounds between non-metal and non-metal, we know the first of all we know the kind of bonding they show is a covalent bond, because they just share an electron, and the type of bond they show is an ionic bond. We have discussed in the previous units as well. So when you are making a covalent bond between the non-metal and non-metal, so we have the molecules, right. So what is the molecular formula for that? So whenever we indicate the molecular formula, we use the terms mono, di, tri for indicating the number of atoms which are present in it. For example, to make you understand, I am writing an example. See, we get to see nitrogen. Nitrogen shows so many variable valencies, right? So I am just picking the compounds of various nitrogen and oxygen, and just let you know that what is the difference of naming them. So we get nitrogen as N2O also, we get NO also, we get N2O3 also, we get N2O5 also. So that means there are many nitrogen and oxygen compounds, because nitrogen show variable valency. So what is the basic thing that I need to tell you, that where this mono, di, tri is being used? So where it is used, it is just used as a prefix. The mono, di and tri is going to indicate, they will act as a prefix. That means they will be written at the starting of the name, right. Like this is nitrogen and oxygen, right. So I am just writing nitrogen and the other element is oxygen. I have written it. Now the question comes, how many nitrogens? What you can see? 2. So I am just prefixing dinitrogen oxygen. So its name becomes dinitrogen oxygen, right. And when I am talking about this NO, what does this becomes? That is nitrogen, again oxygen. How many nitrogen? 1. How many oxygen? 1. So it is nitrogen. Sorry, one more thing I need to tell you, I missed it. It is dinitrogen, and the second part you need to write the oxide. Means oxygen will no longer become as this, it will become oxide. So it is dinitrogen oxide because it ends with a negative radical, so oxygen always ends with IDE, right. And when we are talking about NO, so it becomes nitrogen oxide. How many oxides? Monooxide. So its name is nitrogen monooxide. And when I am talking about this, again I am writing nitrogen, oxygen as oxide. How many nitrogen? 2. So dinitrogen. How many oxygen? Tri. So it is dinitrogen trioxide. Similarly, dinitrogen 5 means pentaoxide. So this is how you are going to name the compounds of non-metals and non-metals. Don't forget, as I forget when I was explaining you, don't forget to write the oxide, right. Don't write oxygen, it's wrong. You have to write the oxide, right. So this is how you are going to name the non-metal compounds, which are just bonded to each other by covalent bond. Similarly, we have the compounds between the two elements and the oxygen, right. For example, you can say the example coming in my mind is KClO3 and KClO2, right. What you call them? See, it is, so how you will be writing this? See, they both appear to be same. They consist of 2 elements, as I told you, 2 elements and oxygen. Oxygen can be 1, 2, 3, 4, any, right. So when you are writing the formula for this, or when you are writing the name for it, you need to write the name of the 2 elements first. So that means it is potassium, potassium, clo. Now what I am doing is, which out of them which will contain less oxygen, or you can say which will contain the one more oxygen than the other, its name is going to end with ATE. So that is why I am writing its name as potassium chlorate. And see, it has 1 oxygen less than it, so its name is potassium chloride. So what is done? the suffix used is the one with the more oxygen is as 8 and one with the less oxygen as 8. Similarly in this, it is used as prefix, that is if it is 1 then mono, if it is 2 di, here di, tri, these are all acting as a prefix. And in this what we are doing, we are using the suffix, that means the suffix is just changed to ide, ide. So this is how we are going to write the chemical formulas, and just to make you more familiar with it, I think it's clear now. Just to make you more familiar with it, I want you to know that I should state few examples for you, and it should be clear that how more molecular formulas can be formed. Right. For example, we have magnesium hydroxide. How I will be writing the formula for it? Again, I will be using a metal, Mg, hydroxide, OH. The second step, I will be writing the valency for it. I remember it's 2 positive and it is negative. Hydroxide is a radical with a negative valency. So I have just written it, right. Now the next I will be crisscrossing it like this. I will be writing this 2 this side and the 1 this side, right. So whether I write or not, it does not matter, because whether you write 1 or not, it means the same. So do you think this formula is right? Tell me, do you think that this formula what I have made is right? No, it is wrong. It is going to be absolutely wrong. The reason being, see, this radical contains 2 atoms. Radical is that the group of atoms that bears a charge. That means it has the oxygen and hydrogen. But when I am writing this 2, this means this 2 is only specified by the hydrogen atoms. It has no link with the oxygen atom. But hydroxide behave as a 1 unit. So that means it is wrong. Whenever you see a radical, you need to just enclose it in a bracket and write the value which you have crossed with. So this is a right formula, but this, if you write this kind of formula, it is going to be wrong, right. So whenever you get a radical and you are just crisscrossing, you need to write the valency, and you just need to enclose that in a bracket, indicating that this 2 is assigned to the particular elements which are enclosed in the brackets. Right. So this is how you are going to write the chemical formulas, and you are just going to write the prefixes. And again I am telling you again the same thing, if you wish to have a good hand in chemistry, you need to know, or you need to well versed with the valencies. Once you will be well versed with the valency, chemistry is going to be on your tips. Just keep this my advice with you, and just when you will do that, and just see to it that if you compare yourself with your classmates, you are going to succeed. Because if somebody is not well versed with the valencies, he is 0 in chemistry, because chemistry doesn't understand the paragraphs, it understands, or you can say the chemistry talk on the basis of chemical reactions. So just be familiar with the valencies, because if you will know the valencies, then only you are going to build the chemical formulas, and if you are going to mention the chemical formula, then only you will be able to do the chemical reaction. So just make yourself well versed with the valency. Nothing is difficult, you just need to recall them, and 1 to 20 atomic number is so easy for you. You know that you can just write the atomic number with this thing, the configuration, and just can pick the valence shell electron. But after that, I think that after 20 elements with atomic number 20, it will be difficult for you. So just what's a big deal? Just write them, just make a tabular chart, just make a you can say a chart on which the valency chart, just place on the thermocol, and just wherever you sleep, just this thing, keep it that side, like pin it on the wall, and whenever you get up, just make a habit to read it, and I'm sure that within a week you will be familiar, you will be more good in the valencies if you will compare yourself with me, right. So just the one thing that I want to tell you, just do it, you can do it, and the valency is not a big deal.